Hello and welcome, my dear grade 9 elite students, to my channel Mathematics Made Easy. In today's session, we are covering lesson 11.5, which is using the distributive property. We are going to talk a lot about factorization in today's session. This video is one of the most important topics that we are starting for term 1. And our learning objective in today's session would be to factor polynomials by using the GCF, distributive property, grouping, and additive inverse. Before we dive into the video, I would request you to watch the video till the end so that you understand the concepts of factorization, you understand the different methods that we'll be covering today in deep, and also a humble reminder, a kind request to subscribe to the channel if you're watching my videos and finding them useful in your understanding of mathematics. So let me give you the meaning of the word factoring first of all, because it is very important to understand how is factorization different from the multiplication that you've been doing till now for some time. So when we started this module on polynomials, you started with doing addition, subtraction, multiplication of polynomials. We dived into the distributive property. We also did a lot of FOIL method. But in today's session, we are going to do the completely opposite. That means we are going to express now a given polynomial as the product of monomials and polynomials. So in a way, you could say that factorization is the opposite of multiplication, and the method that you are going to use in today's session is called factoring by grouping, where we are going to use a lot of distributive property. So you will use the distributive property to factor some polynomials having 4 or more terms using the method of grouping and regrouping. So let's dive into the video and see the key concept for today. Okay, so I'm going to first give you a concept map for this lesson. So we are doing factorization of polynomials. We are going to do that in this lesson, lesson 11.5, using the distributive property. So now if I divide today's lesson in 3 parts, then the first part of today's session would be where you find the GCF and use the GCF and the distributive property for factorization. So that will be like the first method. Okay, and the second method would be using grouping and regrouping. This method specifically works when you have 4 or even terms, right? And the last method that you will use is using additive inverse, or you can also say using -1. That means, for example, the additive inverse of 1 is -1, so you will just reverse the sign. You have to remember that. So this is method 1 for factorization. You have to really remember this, because as we proceed in more lessons, the method to factorize would increase. So you have to really remember which strategy or which method works for which question. So this method works where there is GCF and distributive property for factorization. This method works where there is 4 or even terms. So this is method 2. And this method is going to work for factorization. And as you saw in the previous slide, factorization is opposite of multiplication. So you are given a polynomial and you are going to write it as product of monomial or binomials. So let's start with the first method using GCF and distributive property in the next slide. So method 1, which works for factorization of polynomials, is the method which we are doing of GCF and Distributive property. So let's recall a little bit. GCF is the greatest common factor. So if you get a question like this, I'm taking a question. This is question A from the check of your math book given on page 662. So you are given to factor 33n cube minus 121n square. So if you see there are two terms, it's a binomial. So we have to factor it and write it as product of monomials. Okay, so let's look at the first term. See, this is the first term. This is the second term. So let's take the first term, 33n cube, and let's factor it. So step 1 of a factorization question would be to factor each term. So I'm factoring 33, the number as 3 multiplied with 11. So prime factorization, that's how it works. And n cube means n multiplied with n multiplied with n 3 times. Next, I factor the second term which is given, which is 121n square. So 121 is a perfect square of 11. So I can write 11 multiplied with 11 and 2 times n. Now, in step 2, you are going to take the greatest common factor. What do I mean? You have to take GCF. So what is common here? Let's see. In number, 11 is common. In variables, n square is common. So what is the GCF? 11n square. Now that you have your GCF, we'll now proceed to step 3 and write the given polynomial. I'm writing the question one more time as equal to the GCF multiplied. Now comes your distributive property. What is the sign in between? Negative. So what should I multiply to 11n square? If I change my color, see, 11n square I've already taken out. So what is left? 3 and n. So 3n, and what is left here? 11n square is taken out, 11. So this is what will remain. So have I written this as product of monomial? This is monomial, definitely. And this one is binomial. Have I done that? Oh yes, that means the factorization is complete. We are going to take one more example from the book where there are 3 terms and do the same method so that you become more confident. The second example that I'm taking is again from the math book. It's from the check. It's B part on page 662 of your math book. So the question is 14 a square b square c minus 6 ac square plus 10 ac. Okay, now count the number of terms. 1, 2, 3. Let's factor it using GCF and distributive property. So we are going to factor each term. That's step 1. Step 1 of solving the question is to factor each term. So a square b square c, 6ac square and 10ac. So 14 can be written as 2 multiplied with 7. A square is a times a, b times b and 1c. 6 can be written as 2 multiplied with 3, a times c, and 10 can be written as 2 multiplied with 5 times a times c. So very easy to identify. The GCF is 2 here in the number, a in the variable and c also in the variable, which is the common. So step 2 would be to get the GCF, which is 2 multiplied with a multiplied with c. Step 3 would be to write the question itself. 14 a square b square c minus 6 ac square plus 10 ac is equal to, now first we write the GCF, 2ac, then inside what is left? 7ab square. 7ab 2ab square minus, the sign will be as it is, 3c and 5, and that's all. So this is the factorization. So you have written the given question as product of a monomial and a trinomial. So that's where your factorization is complete. So that is all about the first method where you use GCF and distributive property. Let's try and solve some mixed exercises from your math book. This is page 665 and 666. The problems that we will be solving are 30, 31, 5 and 6. So let's solve them in the next slide one by one. Okay, so first we are solving the questions from page 665. So we are going to do question 5, which is 4a square b square plus 2a square b minus 10ab square. So I assume now you are more confident in doing the GCF and the factorization. So we are going to go a little quick in our factorization. So this can be written as 2 multiplied with a multiplied with a multiplied with b multiplied with b. These are the factors. This can be written as 2 multiplied with a multiplied with a multiplied with b. This can be written as 2 multiplied with 5 multiplied with a multiplied with b multiplied with b. So what is the GCF? 2 from here, a from here and b from here. So our answer 4a square b square plus 2a square b minus 10ab square can be written as 2ab times, oh, we forgot 1 2 here. So 4 can be written as 2 multiplied with 2. So therefore there will be 1 2, then AB plus A plus 5B. So that is what you will get here in the factorization. Let's do question 6. Factorize 5c square v minus 15c square v square plus 5c square v cube. So now I'm going to go a little quick. So the factorization of 5c square v, 15c square v square and 5c square v cube is easy now. See, this is 5 multiplied with c multiplied with c multiplied with v. This is 3 multiplied with 5 multiplied with c multiplied with c multiplied with v 2 times. Then 5 multiplied with c multiplied with c v 3 times. So what is common? In the number 5 is common, in the variable c square and then v also. So answer would be, factorization is 5c square v, where inside you have 1 minus 3 times v plus v square. So this is your factorization using GCF. So here the GCF was 5c square v. Here the GCF was 2ab. So that's your GCF and distributive property. I hope you have understood the method 1 for factorization, and if you did, do let me know in the comment section. Give this video a thumbs up if you found it useful in understanding factorization using GCF and distributive property, and wait till my next video, which will be on the second method using grouping and regrouping. Don't forget to subscribe to the channel and press the bell icon if you like the video so that you don't miss the upcoming videos of my channel. Until then, this is Ms. Ruchika signing off from today's session. See you in my next video. Bye, students.